Hello, welcome to ANS Solver. This is the seventh question of the paper, and as you can see, it's a complex number question. So we need to solve for z and give the answer in the terms or the form x plus iy. So if you see, you notice this is a quadratic. So the formula for a quadratic is simply minus b plus minus the square root of b square minus 4ac over 2a. Correct? So now simply substituting, I know this is my B, this is my A, and this is my C. So minus of minus 4 plus 3i, okay, plus minus the square root of B square, which is simply minus of 4 plus 3i, the whole square, minus 4 into A, which is 1 plus I, into C, which is 5 plus I, over 2A. So now to solve this, this is a long process. So yeah, that kind of patience will be required, but it's okay, you can do it. So now I'll get 4 plus 3i here, because minus minus will cancel, plus minus the square root of, this is simply 4 plus 3i the whole square. Okay, so I can write it as 4 plus 3i the whole square minus 4, and I can expand this to get it like 1 into 5 plus I plus I into 5 plus I. Okay, it is over 2 plus 2i. So now I can write this as 4 plus 3i plus minus, I know this is simply a plus b the whole square, so I can write it as a square plus b square plus 2 into a into b. Okay, minus 4 into, I can write this as 5 plus I plus 5i plus I square. Got it? Upon 2 plus 2i. So now I can write this as 4 plus 3i plus minus the square root of 16, because 4 square is 16, plus 9i square plus 2 into 4, 8, 8 into 3 is 24. So 24i minus 4 into 5 plus 5, I square can be written as minus 1. So 5 minus 1 will be 4, okay, plus 6i, correct? This is what I can say, over 2 plus 2i. So now I can write this as 4 plus 3i plus minus the square root of, I told you all I square can be written as minus 1. So I can write this as 16 minus 9. 16 minus 9 gives me 7. So 7 plus 24i minus 16, okay, because when minus 4 goes inside, minus 16 minus 24i, okay, over 2 plus 2i. So now I can write this as 4 plus 3i plus or minus the square root of 24i, and 24i will cancel off because there's a minus, and 7 minus 16 is 9, minus 9, over 2 plus 2i. Now we all might be thinking, how do we solve something like this? Simple. You can write this as 4 plus 3i plus or minus the root of minus 1 into the root of 9 over 2 plus 2i. Correct? So now I can write this as 4 plus 3i plus or minus, I know minus 1 is simply I, and root of 9 is 3. So I can write this as 3i over 2 plus 2i. Now, what I can do is I can write this as 4 plus 3i plus 3i over 2 plus 2i or 4 plus 3i minus 3i over 2 plus 2i. So I'll write this as 4 plus 6i over 2 plus 2i or 4 over 2 plus 2i. Now, let's just focus on this. How do we change this into the x plus iy form? Simple. You need to know, you need to multiply the conjugate to the conjugate of the denominator to the denominator and numerator. Rationalize basically. So I can write this simply as 4 plus 6i over 2 plus 2i multiplied by the conjugate of 2 plus 2i is simply 2 minus 2i, because in the conjugate only the sign of the imaginary part changes. So I can write it something like this. So now I can expand to get 4 into 2 minus 2i plus 6i into 2 minus 2i. And if you notice here, this is basically a plus b into a minus b, which I can write as a square minus b square. So I can write this basically as 4 into 2 is 8 minus 8i plus 12i minus 6 into 2, which is 12i square over 4 minus 4i square. So now I know I square is equal to minus 1. So I can write this as plus 12, because minus 12 minus 1 will give me plus 12. 12 plus 8 is 20 plus minus 8i plus 12i gives me 4i. And this will be over. I know I square is minus 1. So I'll get 4 plus 4, which is simply 8. So now finally I can write this as 20 over 8, which is simply 10 over 4. 10 over 4 is 5 over 2. So 5 over 2 plus 1 over 2i. This is my first value of z. Got it? Now, the second value. Say I do the same thing. Write 2 minus 2i here. 2 minus 2i here. Correct? We know the denominator here will simply give me 8. Correct? This is what we did. So I can write this as 4 into 2 minus 2i over 8, which can give me 8 minus 8i over 8. Correct? So now I can write this as 8 over 8 minus 8i over 8. So I'll get my answer here as 1 minus I, which is another value for z. So both of these are my answers. Yeah. Now, the B part. The complex number u is given by, so they have given us a complex number. So on the sketch of an Argand diagram, we need to first show a point representing u. Okay. So, where will u lie? If you see u, the coordinates is simply minus 1, comma minus 1. Because there's minus 1 in the real part, minus 1 in the imaginary part. So I'll have simply minus 1 somewhere here. Okay. Now, if you see here, this is something called as a perpendicular bisector. Okay, this is the form of a perpendicular bisector. Z basically means Z minus the origin, which is less than Z minus 2i. So simply, I'll write this in red. My coordinates here is the origin, which is 0, 0. And here my coordinate is simply 0, 2. because this is the form, there's a minus always in middle. So 2 is the imaginary. Okay, this basic concept. So 0 comma 0 lies somewhere here, correct? And I can say, just 1 second, 0 comma 2 lies somewhere here. So now, if you see this, I need a perpendicular bisector between this red line. Okay, which will look something like this. Okay, this is how it will look like, a perpendicular bisector. It's 90 degrees. Got it? Now, what we need to do is, we have the argument of z minus u, which is basically this point, okay, to be between 1 upon 4 pi to 1 upon 2 pi. So 1 upon 4 pi is something like the 45 degrees, basically. So it will look something like this, okay, and 1 over 2 pi is 90 degrees. So it will look something like this, okay. Now the main question comes, what do we sketch? Okay, which color? I think I should take purple. See, look at the perpendicular bisector here. Okay, they want the perpendicular bisector because it's a less than sign, it should be closer to the origin, correct? Because wherever it's less than, it should be closer to that. That means the direction of this green line is something like this. Now I need argument of z minus u between both of these lines. So the attraction is something like this and this. So now if I see, if to match all the criteria, if I shade the area here in between, it's matching all the inequalities because it's less than the green line and it's between 1 upon 4 pi and 1 over 2 pi. So yeah, area in the purple is basically the shaded area.